So, looking at translations of sine and cosine. So, if we add two more variables into our generalized sine and cosine curves, we would get the following. Now, we're going to start with just c, though. So, c is going to be affecting the value of x. So, that's going to cause a specific type of transformation. And specifically, it'll cause horizontal ones. So, if we look at and compare with and without that constant c in there, we'll see that there's going to be a shift of c over b. So again, be careful with the minus in there. So just like with translations from before, if we're subtracting from x, that actually does the opposite and shifts it to the right. So this is going to cause a horizontal shift to the right of c over b, and that shift is called the phase shift. So in total, we have the following summaries. So looking at the whole picture, we got A in front is going to be our amplitude. So be careful, make sure you have the absolute value of it though. Our period is affected by the value of B, so that's always going to be 2 pi over B. And now we have the shift left and right. So the left end point of your cycle is going to be x equals c over b, and then your right end point will be 2 pi over b plus c over b. So essentially a way to think of this is the period plus the shift. So the period plus the shift, and that will give you your right end point. So now let's kind of break down what we have. So for this one here, we're going to have an amplitude, and that's going to be your number in front, so that's 2/3. We're going to have our period. So in this case, x over 2, remember that's going to give you a b value of 1/2. So 2 pi over 1/2, which we already showed before, that was equal to 4 pi. And now we have our shift. So because it's minus, our value of c is technically positive, so it's going to be shifted to the right. So our left endpoint should be c over b. So we got pi over 4 divided by our value of b, which is 1/2. So if we multiply the top and bottom by 2, that's going to give you 2 pi over 4, or just pi over 2. So that means our right endpoint should be 4 pi plus pi over 2. And we can easily make that into a singular fraction. So that's 8 pi over 2 plus pi over 2, which is 9 pi over 2. Okay, so now we got to be careful about scaling. So amplitude will take care of our vertical. So we want 2/3 and minus 2/3. And now, remember, our period is always our fourth dash. So 1, 2, 3, 4. So that's going to be 4 pi. And so now we can label the rest of these. So that we got 2 pi and pi minus pi and 3 pi. And so this would be 5 pi. All right. Now, without shifting it, we're talking about cosine, so normally we would start up here, and then we would kind of work our way through. That's technically where we would normally be without the shift, but we got to shift it to the right pi over 2. So pi over 2 is just going to be halfway, half of a dash, essentially. So each one of these points gets shifted over a half a unit. So that would put them right here. And this last dash should be that 9 pi over 2. And the first dash will be the pi over 2. So everything lines up. And so now we can sketch our curve in. And if you want to make it pretty, you can erase the old stuff. So there should be your graph. And then D is going to be causing vertical shifts. So now D could be added to the front, which they've done here, but it could be added after the parentheses as well, and it does the same thing. So let's take a look at that. Maybe we'll make this video a little longer. Okay, so we're going to do the same thing. We want to identify all of our key ingredients. Let's start with the amplitude. So now be careful. The amplitude is not 2. It's the number in front of your sign. So in this case, it's just a 1. So the amplitude is 1. Our period. So, okay, so now the value of B is this yucky fraction, 2 pi over 3. Zzz. So we want 2 pi over B, but B is a messy fraction. So now we got to simplify that. So this is essentially 2 pi over 1 times the reciprocal. So that's just equal to 3. So the period is equal to 3. And now, is there any shifts left or right? So are we affecting the value of x inside the parentheses? We're not. So there is no phase shift. And then the 2 in front, we know that that should go up 2. All right, so our amplitude is 1. So our scale vertically should be by 1s. Horizontally, we got to base it off our period. Remember, the 4th dash is always the period, so that's going to be equal to 3. So now we got to just be careful. So half of 3 is 1.5. Half of 1.5 is 0.75. And then the 3rd dash, well, an easy way to get the 3rd dash is to multiply the first one by 3. So that's going to be 2.25. So this dash would be the negative 0.75. So now we're all labeled. Okay, we're dealing with sine. Sine normally starts at 0. I'm going to use x's again because we're going to shift it. So now if you can do this without doing the x's, obviously go for it. But sometimes it's nice to draw it without the shift. And then, you know, so you can kind of see it and then say, okay, I got to shift each one of those up 2 units. So that's going to go up here. We'll have a point there. This one goes up 2. This one goes up 2. And the last one. So we have our curve kind of floating up in there. And so that should be our translated curve. Okay. So sketching the graphs can be a little bit interesting, but you got to just be careful. The scaling is the big thing. That's all I really care about, is making sure you scale it appropriately. And as long as you remember the 4th dash is always your period, that's half the battle right there. So, okay, now a couple of applied problems. Find A and D for the functions. Now, because I don't have the textbook out, I'm going to stop the video and we'll do those last 2 in a new video. All right, see you in a minute.